A unique new AMC automobile with full-time four-wheel drive. Its chassis has some unique features that call for some special service procedures. This dealership training kit on the Eagle chassis is somewhat different than others you may have used. A film is still the heart of the kit, but there is no reference booklet or bench chart. Instead, we want your honest opinion of the film program, and we want to see how effective this particular film is as a training aid. So this kit contains a special program evaluation form and a brief quiz on the key facts covered in the film. To give us a true picture of our efforts, we need your response, and we need as many responses as possible. It could be a rewarding experience for both of us. For you, because we've arranged for a special sweepstakes prize drawing as an incentive for you to complete and mail us your evaluation form and quiz. And for us, because your response will help us develop improved training programs to help you provide the best possible service for our customers. The prize information folder gives you the drawing details. It also shows you what you can win for a few minutes of your time. There are 10 exciting prizes to choose from, and there'll be 25 winners in all. With that in mind, let's talk about the film that you're about to see. It's designed to help you learn what you need to know for working on the Eagle chassis. The training film covers the unique features of the Eagle chassis. The discussion follows a logical path. Power flow from the engine through various chassis components to the wheels. Along the way, we'll talk about the Eagle's transmission, transfer case, propeller shafts, axles, wheel bearings, brakes, steering, and suspension. In addition, the training film highlights the service procedures that set the Eagle apart from other AMC cars and Jeep vehicles. We'll start our discussion with the transmission. For 1980, the Eagle is equipped with the Model 998 Torque Command automatic transmission. This is the same unit that was previously used in AMC V8 applications. The transmission has a conventional, non-lockup torque converter and a 3-speed planetary gearbox. It is coupled to the Eagle's transfer case by a special adapter. Engine torque is transmitted to the transfer case, driving straight through to the rear propeller shaft and offset through a chain to the front propeller shaft. You should be familiar with the service procedures for this transmission. If not, please review Training Release 79-4, Torque Command Transmission. The only new service procedure you will need to know is that for replacing the housing seal on the special adapter if leakage is diagnosed. This seal is installed using special tool J29162. The replacement procedure is detailed in your technical service manual. Next, let's talk about the Eagle's transfer case. The Model NP119 transfer case provides full-time, single-speed, four-wheel drive. The outstanding feature of this case is a sealed viscous coupling. This coupling provides limited slip for an interaxle differential between the front and rear output shafts. 2 drive sprockets and an interconnecting chain are used to distribute torque to the front and rear propeller shafts. One key service procedure for this transfer case is that of checking and changing the lubricant. The only acceptable lubricant is a quality-grade 10W30 motor oil. This lubricant should be checked at 5,000-mile intervals and changed at 15,000-mile intervals. The specified oil fill is 3 pints. You can check for the correct level by removing the fill plug and touching the oil with your finger. Other service procedures for the Model NP119 transfer case are detailed in your technical service manual as well as in Dealership Training Release 80-3. But remember, you should always check other driveline components before attempting to tear down a transfer case. The actual cause of a drivability problem may be traced to the transmission, propeller shafts, axles, hubs, wheels, or tires. Now, let's follow the power flow to the Eagle's propeller shafts. As we've mentioned, the power flow to the rear prop shaft is direct through the transfer case, while the power flow to the front prop shaft is offset through an interconnecting chain in the transfer case. There are several key features to remember about the Eagle's propeller shafts. Clamp straps with bolts are used to attach the shafts at the axle yokes and transfer case yokes. The universal joint bearing cap retaining rings are internally mounted, and each universal joint has a lubrication fitting. Key service procedures that you will need to know about include those for shaft removal and installation, shaft runout measurements, and universal joint lubrication and angle measurements. These procedures are detailed in your technical service manual and are similar to those for the propeller shafts on other AMC cars. However, there are some important differences. For instance, during prop shaft removal or installation, you may need to use a special tool for the bolts on the clamp straps. Several types of bolts have been used to date in production. The torque spec for these bolts is 17 foot-pounds or 23 Newton meters. Another difference is seen in the propeller shaft runout specifications. The allowable shaft runout is much less on the Eagle than on other AMC cars. Runout must not exceed 10/1000ths of an inch at either the front or rear of the shaft, and must not exceed 15/1000ths of an inch at the center of the shaft. Other differences are found in the service procedures for the universal joints. One involves lubrication. The Eagle's universal joints have lubrication fittings and should be lubricated with chassis lubricant at 5,000-mile intervals. The universal joints on other AMC cars are factory lubricated for the normal life of the part. A second difference involves angle measurements on the universal joints. As you know, inclinometer tool J22910 is used to take two readings at each end of the propeller shafts. Only positive angles are acceptable. Negative angles must be adjusted using shims. However, the universal joint angles on the Eagle's front propeller shaft cannot be adjusted using shims. If negative angles are found, the problem lies with worn or defective engine mounts or damaged front axle attaching parts. Such parts must be replaced to adjust the universal joint angles. Before we go any further, let's review what you've just learned. Can you answer the following questions? 1. What is the only acceptable lubricant for the Eagle's transfer case? 2. What is the maximum allowable runout at either end of the Eagle's propeller shafts? And 3. How do you adjust negative universal joint angles on the Eagle's front propeller shaft? The answers are easy. The only acceptable lubricant for the Eagle's transfer case is 10W30 motor oil. The maximum allowable runout at either end of the Eagle's propeller shaft is 10/1000ths of an inch. And the only way to adjust negative universal joint angles on the Eagle's front propeller shaft is to replace defective parts such as damaged engine mounts. The angles cannot be adjusted using shims. Now let's pick up the power flow where we left off and follow it into another chassis component, the driving axle. Two different types of driving axles are used in the Eagle's four-wheel drive system. For driving the rear wheels, the Eagle has the same semi-floating 7 9/16 inch axle that is used on two-wheel drive AMC cars. For driving the front wheels, the Eagle has a unique axle design called the Model 30. This axle has a central differential with short, articulated half shafts for use with the Eagle's independent front suspension. In this film, we'll concentrate on the Eagle's front axle. You should already be familiar with the servicing procedures for the rear axle. Your technical service manual is a good source of information. Also, you can use Training Release 80-5 for basic facts about driving axle overhaul. And for some real hands-on experience, be sure to attend the AMC Jeep Service Training course on driving axles. Let's first position the Eagle's front axle. Looking forward from the center of the Eagle, the front propeller shaft and the axle differential are offset to the left, with the axle tube extending to the right. The front wheels are suspended on upper and lower control arms with a coil spring between the upper control arm and the wheel housing. Torque is delivered to the differential by the Eagle's front propeller shaft. The differential distributes torque to the axle half shafts according to the driving situation. The half shafts then transfer this torque to the front wheels through a unique axle hub and bearing assembly. This assembly is mounted in the steering knuckle, and the disc brake rotor fits on its wheel mounting studs. The front axle is attached to the engine rather than to the frame. There is a mounting bracket on the front of the axle housing and a mounting bracket on the rear of the axle housing. One important step to remember when working on the Eagle's front axle is that you must not damage the protective boots on the half shaft joints. The boot seal around the joints is critical to joint life. As such, always install the special boot seal protectors J28712 on the boots before removing or installing the Eagle's front axle assembly. There are a few other axle features that affect servicing procedures. For instance, inside the axle housing, you'll find that 2 C-clips retain the axle shafts in the differential. These clips must be removed before you can remove the axle shafts. Another feature is that 2 different types of axle shaft bearings are used on the Eagle front axle. The left side, or short axle shaft, uses a ball bearing, which is mounted in the axle housing. The right side, or long axle shaft, uses a needle bearing, which is mounted in the axle tube. Here are the locations for the differential bearing shims and the pinion bearing shims. Compared to standard AMC axles, the differential shims are now located behind the bearings rather than between the bearing races and axle housing. One last but very important item about the axle itself concerns axle end play. The end play specification for this axle is 33 thousandths of an inch to 88 thousandths of an inch. An out-of-spec end play on either axle shaft can be corrected by replacing the axle shaft assembly. Now let's talk about the axle half shafts. They are 11.62 inches long and have an enclosed constant velocity joint on each end. One end of the half shaft is bolted to the axle shaft flange. The other end is fitted into the hub and bearing assembly. 3 types of half shafts have been used on the Eagle to date. Early production used a Type A half shaft, which was subject to a safety recall campaign. The service correction and later production used a Type B half shaft, as well as an improved Type A half shaft. The Type A half shaft has 3 ribs on the inboard boot seal, while the Type B half shaft has 5 ribs. There are also differences in the casting finish. The improved version of the Type A half shaft has a yellow paint mark on the inboard flange. You should refer to the appropriate diagnosis and repair bulletin for servicing information. The Eagle axle half shafts have Rizepa joints outboard and pot-type joints inboard. Each of these joints is protected from moisture and dirt by special boot-type seals. These seals should be checked for damage every time the vehicle is raised. One service procedure that you'll need to know is half shaft removal. After raising the automobile, remove the wheel and the disc brake caliper and rotor. This new design rotor is held to the hub by the wheel. With the wheel off, it is loose. Next, remove the hub nut cotter pin, the lock nut, and the hub nut itself. Then, as we mentioned earlier, install the half-shaft boot seal protectors J28712. These protectors not only protect the seal, but also support the half shaft to prevent joint disengagement. Next, remove the bolts attaching the half shaft flange to the axle shaft flange, and lower the half shaft from the axle flange while pulling the half shaft from the hub assembly. With the half shaft removed, you should inspect the mating surface of the axle shaft flange. Make sure that the inner recess has no nicks, burrs, dirt, or other obstruction that would prevent solid mating of the half shaft flange. File, grind, or scrape as necessary to remove any obstructions. Also, make sure that the axle shaft flange recess is chamfered about 40 thousandths of an inch. Use a small rotary grinding stone to increase the chamfer if necessary. The installation of a half shaft is basically the reverse of what we've just done. If it is a replacement shaft, make sure you install the boot protectors. First, insert the splined end of the half shaft into the hub. Then, raise the shaft to the axle shaft flange and align the bolt holes. The flanges should mate solidly but should not be forced. While holding the flanges together, install one upper bolt and tighten it to snug. Then install the remaining bolts and tighten all of the bolts to 45 foot-pounds or 61 Newton meters. Next, install the washer and hub nut and tighten the hub nut to 150 foot-pounds or 203 Newton meters. To hold the hub stationary, lower the car until weight is applied to the opposite front wheel and place the transmission in park. Finish the job by installing the lock nut and cotter pin. Complete service procedures for the Eagle's half shaft are covered in your technical service manual. These procedures include disassembly, cleaning and inspection, and reassembly. You should check the manual or an appropriate diagnosis and repair bulletin whenever you are uncertain about any service procedure on the half shafts. For a brief review, let's see if you can answer two questions about the Eagle axles. 1. What types of axle shaft bearings are used on the Eagle's front axle? And 2. What are the two types of joints used in the Eagle half shafts? Did you know the answers? The Eagle's front axle has a ball bearing for the left side or short axle shaft and a needle bearing for the right side or long axle shaft. And the two types of joints used on the Eagle half shafts are Rizeppa outboard and pot type inboard. Now let's take a closer look at the hub and bearing assembly. This type of assembly was used on early Eagle models. It is a sealed unit and it does not require lubrication or periodic maintenance. A dust cover seals the pre-lubricated ball bearings. A different hub and bearing assembly is used in later production. The Type 2 assembly is not sealed. It has tapered roller bearings, which are packed with grease. The Type 2 assembly will require periodic maintenance such as repacking or bearing replacement, while the Type 1 assembly is serviceable only as a unit. The hub and bearing assembly is bolted to the steering knuckle. The half-shaft spindle fits into the hub, and the unique new disc brake rotor fits onto the assembly's wheel lugs. There are a few other chassis features that should be mentioned before we end our discussion. These involve the Eagle's brakes, steering, and suspension. Power brakes are standard on the Eagle, with disc brakes at the front and drum brakes at the rear. The major difference between the Eagle and other AMC cars is how the front disc brakes are mounted. The unique rotor does not have an integral hub. The rotor is held in place between the wheel and hub assembly. Once you remove the lug nuts and tire, the disc brake rotor is loose. The diagnosis and service procedures for this rotor are similar to those for the rotor used on other AMC cars. When measuring rotor runout, you should use at least 2 lug nuts to retain the rotor on the hub. The runout must not exceed 4/1000ths of an inch. The Eagle steering system also has a new twist. A steering stabilizer is connected to the center link in the steering linkage and to the front crossmember. This stabilizer absorbs road shocks and lessens linkage oscillation on uneven road surfaces. And that brings us to our last topic, suspension. As mentioned, the Eagle has an independent coil spring front wheel suspension system. The spring is connected between the upper control arm and the wheel housing. The rear suspension features leaf springs mounted on top of the rear axle. Alignment procedures for this suspension system are the same as on other AMC cars. However, if inspection indicates that an Eagle ball joint should be replaced, the ball joint and control arm must be replaced as an assembly only. Do not attempt to service the ball joint alone. Replacement ball joints will cause fastener interference problems. And that's it. You should now have a better understanding of the unique features found on the Eagle chassis. You should also have a better understanding of its special service procedures. We hope you'll help us out by completing the evaluation form and quiz in this training kit. And we hope you can be one of our winners in the prize drawing.